Hello, in this video, we're going to talk about discrete random variable. So discrete random variable, which are variables or numerical value, is based on the outcome of an event with an associated probability. So earlier, we talked about the data. We have two types, and when it comes to numerical data, we have a discrete data and also a continuous data. So discrete random variable can take on a countable number of possible value, such as 1, 2, 3, 6, 7, 11, 21, something like that, like counting. But continuous random variables can take on all the values in an interval, such as from 0 to 2. These are continuous random variables. Okay, so let's begin. If we let x to be a random variable can represent each of the possible outcome. So a cafe observed the following distribution for the number of cups of coffee sold in a day. So in this case, when x equals to 30, that means there will be 13 cups is going to be sold in that cafe in a day. The probability is equal to 0.5. So when x equals to 36, it means the number of cafe is going to be sold is 13.6 in a day in that cafe. Okay, so 1a. What is the probability that the cafe sold 13.6 cups of coffee? So we want to write it as the probability of, which is P stands for probability of, is the parentheses. We want it to be so 13.6. So that means we want x equals to 13.6. So the probability based on the table, we found that is in here, 0.20. Let me, no, too big. Okay, now, what is the probability that cafe sold 36 or 14.8 cups of coffee? So in the earlier chapter, we talked about all. When you see an all, that means this is going to be an addition. So that means we want to write as x equals to 36, or the number of cafe that we want to sell is equals to 48 is equals to the probability of you selling 13.6 cafe plus the probability of you selling 13.8 cafe. Okay, this is equals to 0.2 plus 0.15 together is 0.35, which is 35% of chance that you're either selling 13.6 cafe or 14.8 cafe. What is the probability that the cafe sold at least 14.8 cup of cafe? So how many scenarios that it will sell less than 14.8 cup of cafe? Well, that means if you're selling at least, that means including 14.8 cups, which we have either you're selling 14.8 cup or more than 14.8 cups. In this scenario, you either have selling 14.8 cups or 60 cups of cafe. So the probability of S selling 14.8 cups, be careful about the equal sign, because at least that means you want to including 14.8 cups. It's equals to the probability of selling 14.8 cups of cafe plus the probability selling 60 cups of cafe. So when you're selling 14.8 cups of cafe, the probability is 0.15 at the probability of 0.35. Together would be 0.5. Okay, next one is, what is the probability the cafe sold at most 13.6 cup of cafe? At most, that means we want to know, hey, the probability at most, that means we want x less than or equals to 36. If it's at most, it should be including 36. So in this example, we have two scenarios, which is either you sold 13 cafe or you're going to sell 36 cafe. So together it's going to be 5% plus 20%, together is 25%, which is 0.25. Now, next one is how many cups of can they expect it to sell on average? So in another word, this is asking you the expected value. So you can think about that this is the rating, the discrete mathematic. So in here, you have 5% of chance selling 13 cups, 20% of the chance selling 36 cups, and 25% of selling 42 cups. So you want to add this together, so we will have the expected value. So the expected value equals to 13 cup, and then you times 5% at 36 times 20% plus 14.2. We might not be able to see it. 14.2 times 25% at 14.8 times 15% plus 60 times 36%. So the sum is going to be 46.4. So that means you expected to sell 47.4 cup of cafe. But remember that statistic is a very applied math. So we want to apply this into a real life scenario. So that means when we answer these questions, you can't just say, hey, this is going to sell 47.4 cup of cafe. That doesn't make sense, right? No one understands what does that mean by selling 0.4 cup. So that means when it comes to this answer, we need to round it down or round it up. So this one, since it's less than 0.5, we need to round down. So 47 cups can they expect to sell on average? All right, so next part is finding the expected value. So remember, this notation means the sum. That means you want to add all the x together, the first x times the probability of first x plus the second x times the probability of the second x. In this case, the first x is going to be what? The 31, and this is going to be the probability of you selling 30 cafe. And this is going to be your S2. This is the probability of X2, X3, S4, probability of X4, so you can distinguish. The reason I want to spend some time to explain this X1, S2, S3, S5, because this might look a little bit confused when you see, okay, adding all the X together. No, actually it means each individual X until you hit to the fifth X, which is we have 5 scenarios, either you're selling 13, 36, 42, 48, or 60 cups of coffee. So variance, in the previous example, we used lots of detail, including our quiz one. I want you to show me the step, how do you get the variance and standard deviation, because we are going to apply and use this again. So for discrete random variable, the variance is equal to the sum of x, each small x, subtract the mean, and then square them times the probability of each x. So in here, I'm going to show you the detail how to get the variance. Later, we're going to use Excel sheet like we did before. All right. So the first step is you want to use each x, xi, I can equal to 1, 2, 3, 4, 5. Subtract the mu Okay, HX we have 30, 13 6 cups, 42, 48, and 60. I know that at the end, I told you that when you answer in the sentences, you need to round this to 47. But during the calculation, you don't want to use the round approximated answer. You want to use the actual value, which means you want to use 47.4. Okay, that is the first step. For the variance, they want you to use all the x, subtracting the mu. And then the next step is we want to square them. So that means after each x, subtracting mu, we square them, whatever the answer is. The answer is negative 7.4 squared, and then negative 11.4 squared, negative 5.4 squared, and then you have 0.6 squared and the 12.6 squared. Okay, and then the next step is after you square them, you will have an answer, which is 300.2. I already calculated that when I prep for the class. You can do it by yourself in a calculator. Okay, so after this is the answer for after they square them, which is the square, and then they want to times the probability, H probability. Like for the first one is what? In here is 5%, 20%, 25%, 15%, and 13.5%. So I've got times 0.5% times 20% times 25% times 15%, and then times 13.5%. And then this is equals to 15.13 equals to 25, 992, 7.92, 0.054, and then 55.566. Then the next step is the sum, right? You want to add these all together, which means I want to add this part together. The sum of what I just circled is equals to 104.04. So this sum is going to be your variance. But we want to find the standard deviation. The standard deviation is equal to square root of the variance, which is the square root of 104.04 equals to 10.2. So that is going to be your variance. Right now, I want to show you how to use a Google Sheet to calculate that. So the first step is you are going to open a Google Sheet, or you can use Excel sheet, either way, whatever that you want to use. First of all, in the previous, we already calculated mu, which is equal to 14.7.4, right? And now hx, I will call it xi, so that I know that, hey, each one can be x1, x2, x3. So xi we have 13, either selling 36 cups, 42 cups, 48 cups, and the 60 cups. And then the first step is you want to use hx to subtract the mu. So we use the function for calculate for us, so which is equal to 30 subtract 14.7.4. You can type in 14.7.4, or I would use the mu. So that means if I calculate the mu, once I change the mu, the whole function will automatically change that for me. And then the next one also use this one, subtract b1. See, they already indicated for you. b1, oops, sorry, which part did it wrong? Subtract b1. Okay. Let me do this again. So equals to this guy, subtract. And the next one, see, they already automatically predict that, hey, you want to use A5, which is the 42, subtract B1, which is the value of 47.4. And then we can just hit return, same, equals to this one. Again, I really want you to try to do it by yourself or just follow me. You can pause the video whenever you can. So the next one is after each x, subtracting the average, the mean, which is mu, you want to square them. So this is equals to the previous answer and then square. The next one, they already predict what you want. Square. And I want these to square equals to this guy square equals to B7 square. All right, so after you square that, this one you might need to put it by yourself. After the SI minus mu, our answer, we square them, we want to multiply each random variable's probability. So I have used this one times 0.005 equals to this one times, oh, did I do it wrong? Yeah, times not 5%. The second one is 20%, which is 0.02. The next one is 25%. The next one is here, 15%, equals to this one times 0.35%. Okay, so after this, we can find the sum. The sum, which is our variance, equals to the sum, which is here. Oh, they already know that because I type in the sum, right? The sum of these guys. Yeah, it's 104.04. And then the standard deviation is going to equals to the square root of this value. Look, done. So again, why do I want to use all of these functions? Because once, maybe at beginning, you put in the mu as 47 instead of 14.4, and then they can just automatically change the value for you. You don't need to put in all of the number by yourself. So this is a good way for you to calculate and check your answer. So that's it for today.